Hi class, this is Mr. Morris again. We're going to be doing some predicting products practice, and the practice is just a little bit different than the notes in a couple ways. So I wanted to give you a short video that kind of introduces you how to do that, and it might do a few examples of the problem that you can skip over if you, or at the end of this, you can skip over them if you don't feel like you need them. Okay. So to start out with, before we can actually predict the products, we need to decide what type of reaction it is. That's the very first step you're going to have to do. We're going to label them in these blanks: synthesis, decomposition, single replacement, double replacement, or combustion. Those are our options. And then from there, you can just look back at your notes and hopefully kind of memorize a little bit how that you're going to identify the type of reaction, or how you're going to identify what the products are. Start out by deciding what type of reaction this first one is. Well, I see that I have strontium and I have oxygen. This is an element, this is an element. If it's just an element with another element, there's only one choice, and that's combining together, which is what synthesis is. So this is a synthesis reaction. All right. The next one that I see is AlCl3. I only see one reactant. It's a compound. If you only have one reactant, there's only one thing it can do. It can break apart. Which type of reaction is that? It's decomposition. Down here, I see an element and a compound. An element and a compound. All right. There's only one option that could be there. Well, and it's not carbon, hydrogen, and oxygen. So element, compound, not hydrogen and oxygen and carbon. So this is going to be single replacement. Single replacement, because one of these is single, the other one is a compound. It's in a couple. All right, and then I have another element, compound, again, single replacement. This one here is a compound and another compound. If you've got two compounds on the reactant side, that's going to be double replacement. That was the wrong letter, sorry. It's double replacement. And then I have CH and O. CH and O2. That's a combustion reaction, which we represent with COMb in this exercise. So that gives you kind of an idea. There's a handful of them. You can work through the rest of these, of course. We'll post the answer key. But I wanted to do a short video where I kind of explained how I thought about those, how I thought through them. If you have questions, let us know. I'm going to do a couple of these examples all the way through. You can skip past this if you already feel comfortable with this. So for synthesis, don't forget we're making a compound. Anytime you're making a compound, you've got to look at crisscrossing the charges. So we got to find SR on our periodic table. SR is here. It's in group 2, positive 2. And then oxygen, I should have showed it to you, but it's a negative 2 charge. So we have SR with positive 2 charge and oxygen with a negative 2 charge. I could write that out, but it's positive 2, negative 2. They're already neutral. There's no need for subscripts. So then we would just balance it. I see that I have one strontium. That's okay. Got 2 oxygen and only 1 here. Let's make that a 2. That also doubled the strontium, so I got to put a 2 right here. And if you'd like to put a 1 here, you can, but you don't have to. All right, this one's breaking apart. It's decomposition, so we've got elements involved. Anytime you have elements, you always check to see if any of the elements are in the 7, if they're diatomic. So I have aluminum, which is not diatomic, and then I have go to 7, make a 7. I think it was chlorine we were just looking at. Chlorine is in our 7, so it is a diatomic element. Yeah, so I have aluminum plus chlorine, and again it's diatomic, so we'll make it Cl2. and then we would just balance it. Aluminum is the same already, but chlorine is not, so I'm going to put a 2 right here, a 3 right here. That doubled aluminum, so I'm going to have to put a 2 right here. And that's balanced. There's another single replacement, or there's a single replacement reaction right here. Don't forget, when you have the single replacement reactions, we're going to have to look at our activity series. Well, I have my notes open, so I'm going to look back at the activity series on my notes. All right, zinc and copper. Zinc and copper. So, looking down, I see zinc is right here, and copper's way down here. Zinc is definitely above copper. Zinc is above copper. Zinc is our single. Copper's in the couple, so the question is nitrate going to stay with the one it's with, or is it going to get with zinc? Well, zinc's more attractive, so it'll get with zinc. Okay. We need to know the charges, and we need to know if they're diatomic. So check if copper is diatomic, and check what the charge of zinc is. Okay, copper is not diatomic, it's right here. Zinc is right here. It's one of those three, +1, +2, +3. So it's a +2 charge. Remember those 3 elements we memorized? Silver, zinc, aluminum. 1, 2, 3. Zinc is +2. And then I believe it was nitrate. Is that? Yeah, nitrate, NO3. If we look at our polyatomic ion list, NO3 has a -1 charge. All right, so let's make that come out to be neutral. First of all, we're going to put copper, not diatomic, so just copper. And we have zinc, which we said has a +2 charge. And then I have NO3 with a -1 charge. All right, we want to crisscross. The 1 goes down here, and the 2 goes down there. All right, get rid of our charges. 1 on the zinc, and a 2 as a subscript on the NO3. Now we just want to balance it. Zinc is already balanced. I have copper is already balanced. I have 2 NO3s. I could balance that as a group, and there's 2 NO3s over here. This is already balanced. I don't need any coefficients. If you'd like to put 1s, you can, but that's not even required. That's kind of the gist of it. It's enough to go through a few examples. If you have any questions, let us know.